Hi, everyone, and welcome to today's webinar. My name is Jason Walls from QA Cafe, and I'm here with Brian DeBreel. He's going to be helping me out with questions at the end. Today, we're going to be talking about some of the higher layer testing hurdles when it comes to testing Wi-Fi routers, APs, and Wi-Fi mesh systems. So first, I want to talk about what I mean when we say higher layer testing. There's a plethora of wireless testing tools that go into the deep engineering aspects of Wi-Fi, particularly the complications that mesh introduces. But here we'll take a user experience perspective when it comes to scalability, performance, and actually testing how necessary protocols behave in a wireless environment. Next, I'll talk about several different test setups in CD router, a basic router with Wi-Fi on the LAN, Wi-Fi on the WAN and LAN, as is used in certain travel routers, a Wi-Fi mesh with several nodes or a repeater, a system with multiple SSIDs used for guest access, and cloud-managed Wi-Fi. And lastly, I want to talk about building an overall automation environment for doing this kind of Wi-Fi testing and how that repeatability helps you produce more robust devices. So Wi-Fi testing is an exceedingly complex subject, and there are experts in the field whose knowledge goes much deeper than anything we'll cover today. And that goes for the tools too. So Wi-Fi testing tools are specifically tailored to low-level radio testing or 802.11 MAC testing that is necessary when building a Wi-Fi system. But what we really care about at the end of the day when it comes to product design and service deployment is the end-user experience. In reality, wireless packet loss will be a fact of life, and you also want to test your applications and services under realistic conditions to see how they're going to behave. What we want to know is how device functions and network protocols, when run over Wi-Fi, will affect the user experience. So just as a quick example, let's take something as simple as DNS latency. Given the number of connections and DNS lookups needed to produce an average website today, as little as 20 milliseconds delay can equate up to 3 seconds of delay to the user, which sounds small, but it's an uncomfortable amount that can quickly escalate. So if that 20 milliseconds goes up even by a little, that delay is going to get much longer. So if we see a problem, we want to be able to isolate which protocols are affected the most, particularly if we're dealing with a Wi-Fi router that is performing some application layer intelligence. Latency in DHCP will also affect the user experience when a device association is lost and must be reestablished. So we've added some of this application layer latency testing in CD router 10.4, and I'll show you what that looks like. So what we try to do is get a baseline. So if you have a device that does have wired inputs, we try to get a baseline so that you can kind of see the difference between what's happening in the wired versus wireless environment. And so when we're doing throughput testing, we're testing the performance of the network processing engine. So we get this baseline, we can know whether it's just the NPE that is the problem before we go to the wireless throughput. And so here you can see, so we have different throughput tests here. We have TCP and UDP upload and download over IPv4. And we also do these over IPv6. But you can see that the wireless introduces radically different results, even between TCP and UDP and upload and download. So these are the things that you can kind of iron out by taking a baseline and then running throughput over wireless. So this also matters when it comes to scalability testing. We've seen many devices that should be able to support dozens of Wi-Fi station connections, but either some internal limitations or bugs have caused them to stop accepting clients altogether, or have other flukes. And we'll talk about this is also affected by the DHCP engine. So if there's if you have your DHCP stack that's handling the clients that are connecting, if there's problems there, you're going to see that with the limitation of the number of Wi-Fi clients that connect. And I'll talk about how this affects repeatability later, but scalability testing is also about measuring how a device performs over time. So do you see loss after a lot of active use? So doing tests that simulate user activity over and over and over again over time to see if your device ends up degrading in performance over time. And when it comes to I have this note about many associations and deassociations. We're actually going to be adding some of those tests in CD Router 10.5, which is going to be coming in a few months. The last point I want to make about the kinds of testing to perform when vetting Wi-Fi devices has to do with verifying functionality verifying the functionality itself rather than the performance of that functionality. So, for example, if your device can be configured to do MAC whitelisting, will it do it correctly? Like if it's set to allow no more than 10 clients, will it hold that limit? Or is it setting up in guest mode? So that two SSIDs are isolated, or in guest mode with isolation where each person connected to the network can't see other people on the network, even though they're all connected to the same SSID. You can see an example of that here. So here we have, a private LAN in the user's network where, all of their stuff is on it, but they have people over and they want those people to be able to connect easily. So they set up a guest LAN. And they also want to make sure that anybody who connects to that guest LAN can't see any other clients on the network. So we want to make sure that we test for that kind of a setup. And lastly, I want to talk about the testing the management interface. Have you verified that when using tier 69, for example, or SNMP, if you're using that in a DOCSIS or a business environment, that the device actually makes changes to its configuration and sets up like setting up a new wireless interface or making changes to it. And this is something that we've added. We've had tests in CD Router for a while, focusing on IGD, but in 10.5 we will have updates for tests that examine that your device can configure Wi-Fi using the device 2 data model. So those tests involve having the ACS simulator send TR69 messages that are going to configure Wi-Fi, like setting up a new network or making changes to an SSID, and then checking to make sure that any simulated clients that try to connect to your AP can do so with the new settings, indicating that your device under test has actually made the changes that you told it to do. So let's go into a couple of test setups for different Wi-Fi devices and how they play out in CD Router. So here's our baseline one. This is a really standard wireless router, right? So it's connected to the WAN. The WAN termination is simulated, and there's a performance source and sink on that side, and that's over a wired Ethernet connection. And then on the LAN side, over various wireless technologies, we're connecting to the AP that's in the wireless router, and then doing all our testing over that. And then we have here, if I was talking about those devices that have what's called Wi-Fi on the WAN, and this is like travel routers or things that you're bringing it to a hotel where you want to have your own settings and your own setup, and it connects to the hotel Wi-Fi on the WAN, and then you connect to it on the LAN. So we have that kind of setup here. In those cases, the WAN termination is simulated on one of the WLAN interfaces. And then here we have a simple connection with a single booster or a single mesh node. And what we do here is actually connect to different BSSIDs in CD Router so that you can test the device that you can isolate each device in turn and run CD Router's tests through that device. And we do that with some settings in the configuration. And then if you want to, if you're not trying to do it in conjunction with your Wi-Fi router, you can actually just test a booster on its own. If it has its own management IP interface, CD router will assign that IP address to it, and then you can run your testing through that. Or you can set it up in bridge mode, much like you would do if you're setting up like a DSL router in bridge mode or a cable modem in bridge mode, and running tests that way. And we have instructions in our user's guide for how to do that. And then obviously is the situation where you have many mesh nodes, and the setup in that case is going to be similar. So you configure CD router to connect to a particular BSSID and run tests through that single device, and that lets you kind of narrow down the behavior of each node. And you can, by putting together several packages and several different configs, you can run those in order and test each device becomes a separate device under test, and you can correlate the results afterwards. And then lastly, I want to talk about cloud managed Wi-Fi. So a lot of people are building, obviously there's been a lot of startups that have done this, but I know some of the bigger players are getting into this, where the Wi-Fi, particularly in a Wi-Fi mesh case, there's still a router, but all of that is managed through some kind of cloud service. And the problem you have there is that if you're trying to test this in a lab, you need to allow access to that cloud service while you're doing your testing. And so CD router has an add-on called ICS, which stands for Internet Connection Sharing. And that actually allows you to route the cloud management traffic, the application traffic, separately from the test traffic. And that's all done within CD router. So CD router is connected to the internet or to your local test network through its interface, and then it routes all of the traffic that's not intended as test traffic to that location, so that when the device under test comes online, it can connect to the cloud service and do its initial configuration, because that's how a lot of these work now. Is some of them won't even become functional until they talk to that cloud service. So we added ICS to take care of that. So lastly, I want to talk about using CD router to automate the entire Wi-Fi test process. So testing any application, particularly over Wi-Fi, requires consistency. And testing manually can't really give you this kind of consistency. And when you're dealing with a system that is going to have unpredictable packet loss, you want to make sure that the meat of your test cases are run the same way every time. So behind the scenes, you know that your wireless environment is going to be chaotic, but you have control over how the tests run. So you know the tests themselves are going to run the same way. And related to this is repeatability. So making sure that you can run tests the same way, but also run them many, many times without the need to intercede. And this helps in two ways. First, running tests many times over the course of a long period will demonstrate how your device reacts to long periods of consistent use. We've seen many cases where this causes some interesting failures. And secondly, because excessive packet loss can cause some test cases to fail, you can use CD router's built-in repeat test on failure option to help filter out test failures based on loss or a functional issue. And I'm going to show you some of that right now. Oh, and here were some of our application latency tests actually that I wanted to show you. So you can see that our DHCP restart here takes a very long time. So you can imagine if your device is disassociating and reassociating and then going through the DHCP startup procedure, and has, that equates to what, 35 milliseconds of delay. That's going to be a pretty harsh experience for the user. Let's talk about this repeatability here. So here the devices, we simulate up to 64 clients on the LAN, and so you can see these all start to connect. And then so in this particular case, something very strange happened. So the device under test started using a key index of 0, which isn't allowed, and then the clients start timing out, and then they all start reassociating. And in the process of that, we have one client down here that all of a sudden, tries to do some of its normal HTTP tests, and the TCP segments end up being out of order. And this is probably a fluke, so we go through and we retest it right here. And then when we retest it, we see that they all work. So because you're in a chaotic environment, when you're doing this protocol testing, you want to make sure that you can do the tests many times over to iron out anything that might just be part of the environment rather than something that's actually wrong with the device. But you also want to see how it's going to behave in such a random environment and try and minimize the times that that's going to happen. So you also want your automation environment to be able to work with other tools and work with continuous integration. So since CD Router 10, we've been putting the focus on using the CD Router interface as an overall automation platform. So with some custom test cases that use our script exec variable or test vars like shutdown dot or restart dot, you can kick off commands to other tools that are part of your automated test run. So if you have some of these more in-depth wireless tools that will help you either want to change the controlled environment or perform some other performance testing using another tool, you can actually use CD Router to schedule that as part of the automation and get your results back. You can either do that through building a custom test case, or we do have some simple scripts that do things at the beginning or ending of a test run. And then I also want to talk about continuous integration. So the biggest hurdle in testing a chaotic system like Wi-Fi is tracking results over time and correlating it with changes to firmware. So using continuous integration like Jenkins, and that works very easily with our API. So you can actually kick off tests and get results using the API. And we have a whole webinar on how to do that with Jenkins and how that can work. But being able to do that lets you sort of do regression testing very easily. So if you end up making changes to your firmware, and you want to make sure that it doesn't affect anything else, you can easily do that in our automation environment. So that's it for now. Before we get into questions, here's some resources. If you do have any questions, our user's guide on the support page is probably your best resources for learning how to do these setups. But we do have a lot of webinars on the topic under our training page on the website. And the two key add-ons I think that probably affect Wi-Fi testing the most in CD Router are the performance add-on, which you can learn about there. And as I mentioned, our internet connection sharing add-on, or ICS, which allows you to test cloud managed devices.